Good afternoon, and thank you for joining us again today. I am Dr. G with High Touch High Tech of Maine, and joining me again, staying safe at home, are Lightning Liam and Explorer Eli. So today we are going to be engineers. Do you know what an engineer is? Who is an engineer? What is an engineer doing? Any idea? What do you know about engineers? Send us a message if you are out there listening to us. Yes. What is an engineer? Building stuff. Any particular stuff? Yes, Eli.
Special stuff like cars.
Cars. Oh, very good. Maybe engineer who builds cars. Any other engineers?
Bridges. Just like
maybe engineer who builds a bridge. Yes. Robots. Yes. Do you like robots? These two like robots. Yes, definitely. What else? Engines, airplanes, computers. What about your refrigerator? Yes. So essentially anything that we build involves engineering, right? So engineering is actually the process of thinking about a problem, solving a problem, designing it, and all the way to actually building it and making it a thing that we can use, like the refrigerator or a road or anything else. So today we are going to be civil engineers and we are going to design, you know what? Bridge. Very good. And we're going to look a little bit at what is really special about some of the bridges. So our supplies for today are 2 cups. It doesn't matter what type of cups. It can be 2 bowls. So really anything that can be like the 2 sides of the foundation where you will put the bridge. So the 2 sides of the river or whatever it is. Whatever you want it to be in your imagination. Then we will also need either gumdrops, but if you don't have gumdrops, we are going to use clay. You may have Play-Doh. So any of it will help. Essentially anything that has kind of a little ball shape and is sticky would work. And then we will need a bunch of toothpicks, 2 pieces of cardstock, few cards, and maybe some rocks, so at the end we can test how strong our bridges are. So when do we usually build bridges? Why do we need bridges?
To get across gaps where cars or other things get.
Yeah, to get across gaps. Yes.
I know, like some places, like you would think that they are supposed to have a bridge, like states that are really close together, and like they
There's
need
a
long,
river in between.
and like they need a long bridge. You would think you need that, but you actually don't because you have boats. But a bridge helps, like not like small gaps, but you know.
So yeah, when maybe you live near islands, maybe some of you live near islands, and some of the islands are closer to the mainland. That's where we will see some bridges. Some of them are very long, right? Can you think about some famous bridges?
Golden Gate Bridge.
The Golden Gate Bridge. Other? That's okay. The Golden Gate Bridge is definitely a famous one. So there are different types of bridges, and today we are going to look. Yeah, go ahead.
Arch Bridge.
Truss Bridge.
Truss Bridge.
Beam Bridge. Right. So we are going to talk about specifically one type of bridge, but we're going also to compare it to another. So what I want us to do first is to look at those 2 pictures. These 2 pictures. And here you can see a lot of different bridges. These are all different types of truss bridges, right? Yeah. What is common to all those bridges? What can you say? What kind of shape you can see in all those bridges? Can you see any shape? Any idea? Okay. So, what do you think, guys?
Triangle.
Triangles. Yes, very good. So Liam said that there are triangles here. Can you see? They're all made of triangles, right? That's pretty cool. So what makes triangles so strong? Do you know? Any idea? When you apply force, when you push really, really hard at a triangle, it's not easy to break the shape, right? Unlike other squares and hexagons and other, it will be easier to destruct, to change the shape. With triangles, it's really hard because the other corners support each other. And that's what makes a triangle very strong and therefore used very often in buildings. So let's think about, maybe you can guess what this one is. Any idea? Any idea what, any idea what this one is? Anybody there? This is the Eiffel Tower. So you see that the foundation of the Eiffel Tower, see, it's actually squares, but guess what? The squares are divided into triangles, right? Pretty cool. So even larger shapes are still divided into triangles. Can you think about some triangles in nature? Yeah. So if you live in New England, you see a lot of those, right? Oops. So pine trees are triangular, right? And that's the same reason that we have them in nature. The triangles are strong, so when there is very strong wind and a lot of snow is falling during the winter, those shapes are not easily affected. Very good. So let's try to make our own triangle and examine how strong they are. So take a bunch of toothpicks, okay, and start arranging them in triangle shape. Okay, so make one triangle and then make another triangle adjacent to it, next to it, right? And continue making triangles. Yeah.
Like at the bottom of that?
Yeah, exactly. So Eli, let's make that. And then take whatever you're going to use, gumdrops or clay or Play-Doh, yeah, whatever you have at home, whatever you brought. I'm going to use clay. And I'll show you in a second near the camera what I'm doing. Thank you. You see, I took the clay and I just put 2 of the toothpicks inside the clay, and then I'll do another one in this corner and another one on the third. And that the clay will allow them to hold together. Okay, so continue doing that. Yeah, go ahead.
It looks like an antenna on a TV.
It does look like an antenna. So that will be your base triangle, you see? It will be the base for your truss bridge. Here it is. Okay, now connect another one on this side. It will be much more colorful if you have gumdrops, but that works. Okay. What do we have here? Want to connect? Yes, you can. Yes, you can. So you see, now connected two. I'm going to connect another one. And then I'm going to repeat it with another structure. Okay. And you can make it as long as you want, so you can continue working on your truss bridge. But I want to show you the basic, two basic units. Yeah, that's very good, Eli. Keep adding more. Oops. So that's one end. Oh. That's one end, okay? Now we're going to do the same with another set, and then we're going to connect them. We like seeing your bridges or any work that you're doing. So if you're out there doing it with us now or later, just send a message to our Facebook page. We like when you share your work with us. So we'll be working on another one. Wow, that's interesting. So I'm going to show you what Liam made here. Oh, he's in the process of finishing it in a second. It's more complicated than the one I made. And that's the other reason why truss bridges, first they're very strong because of the triangular shape, right? But there is something else. Do you think it will take a lot of material to put that one? Not so much, right? So you don't use a lot of material and you still end up with something very strong. And that's really important when you build a big bridge.
This one's funny. Let's go apart.
It's okay. Just adjust it. Perfect. So I'm working on the second one while you're working on yours at home. And soon we'll see how it works, okay? You ready? Okay, so here Liam made much more complicated structure. So now I want Liam for you to connect it into a bridge, right? So yes, your structure is all made of triangles. Now I want to, oops.
And then it's on the ground.
Now I want you to connect it into a bridge. Go ahead.
Okay, I do that.
Oh, okay. You don't?
Yeah, I do. Like what you're doing?
Yeah, so I'm making just two from both sides, and then I will connect them. Okay. So now I have these two, right, from both sides of the bridge, and what's left is to connect all the dots, right? So I'll have one toothpick here, one in the middle, third in the corner, and then another two at the top. Everyone are following?
So how did you do that? How did you do that?
How did you, baby?
Ouch.
Here, yes, sweetie. Good job.
Okay. Oh. How do you make those things?
How do you make them?
No.
I'll help you. How do you can solve it. That's what engineers are doing. They're solving problems. They don't stomp their feet when something doesn't work, right? That's not allowed. Okay.
Okay, like this. This.
So you see how I am putting You see what I'm doing? Oh, maybe the side. You see? I'm going now to connect both sides. Maybe it will be easier if you will stand them up. I think that will be a bridge. And then we want to test it. Remember? Remember what we know so far. Why truss bridges are so useful. They're strong because they're made of many triangles. And they don't waste a lot of materials. That allows to build a pretty large bridge without the waste of material. Okay. Okay. So here's my bridge. You see it? Everyone? Okay, perfect. Now it's ready. So now I need the two sides of the road that I want to connect. You can imagine whatever the gap is. Maybe it's a mountain. I'm sure you have wonderful imagination and you can think about a river. Oh, Liam goes with hot lava. So, of course, you can extend it and continue working and adding more and more. But essentially, just put it between the two, wherever you create your gap, right? However big the gap is. And now we need a road, right? So your road will be this cardstock that we prepared ahead of time. Gently put it on your bridge. And now test it, right? Very important process of engineering is testing your design, right? Because if you don't test your design, is that a complete work? Probably not, right? Okay, so luckily we have few cars in the house. Go ahead and test your design with the cars.
Way too big. 2 cars left.
No.
Oh!
Go ahead. You want to test?
Yes.
Or I'm going to test. Put a car on it. Put a car on it and see if it's falling. Okay, try not to. I'll put too much force. Okay. Okay.
Now it's
Okay. Is it falling or does it seem pretty stable?
pretty stable.
Pretty stable. Can we put some rocks? How many rocks can we put? I brought some rocks. You may collected some rocks from outside ahead of the class, and if not, you can do it later. So go ahead, put some rocks. See how many rocks you can put before your bridge collapses. Go ahead. Test it.
I need one of those toothpicks.
Oh, I have plenty of toothpicks. Okay, great job here. Take a car, take a few rocks. Seems pretty stable, right? So we can see the power of triangles, how triangles work. By the way, do you know what kind of science we're using? Of course, engineering, but we're involving physics and mathematics, right? Forces. So a lot of things are at play when we design something, when we are working as we are today, the work of an engineer. Okay, Liam, I think you hit the limit. It's okay, it's going to collapse. But it took a while before it collapsed. What I want before we go for the day, I want you to test it and compare it with a beam bridge. So a beam bridge is a much simpler bridge. It will look just like that. So essentially, just a road between the two sides of the river. Now, remember that was approximately the distance prior to that when we had the Truss Bridge, but you start seeing that in this case we will have
When you just put it on, it's already starting.
Yeah, it's already started having like
after 3 walks. This
a belly. But when we put the truss bridge, it was much more stable, right? Okay, friends. Well, thank you for joining us today and learning about engineering and bridges and beam bridge and truss bridge. Let us know if you have any questions and be safe. And we'll see you again tomorrow. Take care.